let's go and look at the next problem in the homework for section 9.1. And the problem says the accompanying table shows the height in inches of 8 high school girls and their scores on an IQ test. So IQ stands for intelligence quotient. So we're going to complete parts A through D. So let's go and load up the data. And let's go ahead and copy it into StackCrunch. And then paste it. Okay, so in one column we've got the heights of these high school girls in inches, and in the other we got their corresponding IQ scores. Okay, so part A asks to display the data in a scatter plot and then select the correct graph. Okay, so you might be able to guess what the scatter plot might look like. Okay, but it's always a good idea to do the scatter plot anyway. Okay, even though the problem asks you to select the correct graph. Okay, so we're going to go to Graph and select Scatter Plot. Okay, this time the X variable is the height, and then the Y variable is the IQ score. Okay, you're going to leave the display as points rather than lines. Okay, I'm going to keep the other options selected. And then we can add labels to our axes. The x-axis label will be the height in inches. And then the y-axis label will be the IQ score. Okay, so there's our scatter plot. So remember, each dot in our graph represents an individual. So for example, this dot here is the individual whose height is 63 inches and their IQ score is 112. Okay. So we want to select the scatter plot that looks most like the one we just got here. Okay, and it appears to be answer choice B. All right, next we're going to calculate the sample correlation coefficient. So this time we're going to go to the Stat menu, select Summary Stats, and then Correlation. Okay, we're going to select our two variables, height X, IQ score Y. All right, so as you select the columns that contain your data, okay, make sure you hold down the Control button on your keyboard if you're using a PC, or the Command button on your keyboard if you're using a Mac or an Apple computer. Okay, we don't need the other options. We just need the correlation coefficient, so we're going to go ahead and click Compute. Okay, so according to StackCrunch, right, our correlation coefficient is negative 0.035. Because remember, we're going to round these to 3 decimal places, so negative 0.035. Or negative 0.035. In part C, it says to describe the type of correlation, if any, and then interpret the correlation in the context of the data. Okay, so we can clearly see that even though these data points here, right, they seem to form an upward sloping pattern, right, we have a data point over here, okay, way here in the upper left corner. Okay, so perhaps if this dot was with the other dots, right, then we might say that there's some sort of linear relationship, some sort of positive linear relationship, but that doesn't appear to be the case. Okay, so assuming that this point here is not due to an error in recording the data, okay, it's very likely an outlier in our data set, right? Then there appears to be no apparent correlation or linear relationship between the height in inches and then IQ scores of these high school girls. Okay, so that's how we're going to. Okay, so there is no. Okay, and there is no linear correlation. So in other words, our scatter plot kind of confirms that observation. Right? There appears to be no linear correlation, and also the value of R, which is fairly close to 0, right, indicates that there's no linear correlation. Okay, so anytime you get a correlation coefficient that's close to 0 or equal to 0, right, that likely means that there is no linear correlation. So let's go and check our answer. All right, then we want to interpret this in the context of the problem. So read the answer choices carefully and then select the best one. Okay, so it looks like it's between answer choice B and answer choice D. So let's go ahead and read these carefully to see what they're saying. Okay, so choice B says, based on the correlation, there does not appear to be any relationship between high school girls' heights and their IQ scores. Okay, that's what answer choice B says. Okay, answer choice D says, based on the correlation, there does not appear to be a linear relationship between high school girls' heights and their IQ scores. Okay, so remember, R is what we use to determine the strength of a linear relationship between two variables. Okay, so even though answer choices B and D appear to be saying the same thing, it's actually answer choice D, right? There appears to be no linear relationship between their height and their IQ scores. Okay, answer choice B is slightly different, saying that there is no relationship. Okay, right? All we can tell with the correlation coefficient is that there's no linear relationship, because it's close to 0, there is no linear relationship. Okay, there might be some other type of relationship that's not linear. Okay, but the correlation coefficient does not tell us that. Okay, so that's why you don't want to say choice B, okay, because there might be some sort of relationship that's not linear. Okay, but in any case, right, there appears to be no linear relationship between the heights and IQ scores, so that's the correct answer choice. All right, in part D, it says use the table of critical values for the Pearson correlation coefficient to make a conclusion about the correlation coefficient, and we're letting the alpha equal to 0.0. Okay, so remember our sample size is 8. Okay, we had 8 girls in our data. So for a sample size of 8 and a significance level of 0.01, okay, our critical value is 0.834. So 0.834. So 0.834 is that critical value. All right, so remember, if you get a correlation coefficient that's negative, right, remember to ignore that negative sign, right? Just take the number, which is 0.35, okay, and compare that number, 0.35, or 0.035, right, to our critical value of 0.834. Okay, if it's somehow greater than 0.834, right, then there would be sufficient evidence of a significant correlation. Okay, that's not the case though. Right, again, so again, ignoring that negative sign, right, 0.035 is definitely smaller than our critical value. So what that means is that there is not sufficient evidence at the 1% level of significance to conclude that there is a significance. So be careful there, right? So again, we're saying that there is not sufficient evidence that there is a significant linear correlation between high school girls with heights and their IQ scores. All right, and that completes problem 5 in the homework for section 9.1. Thank you for watching.